So let it download. Yep. So we go into the downloads and we'll start this. So there is some, oh, what is this? Microsoft Defender unauthorized app. More info, run anyway. Okay. So let's accept this. English only. Next. Then go to the main page and get the QCTL also. Next. Finish. So this is also downloading. Good news, huh? The file seems looks as safe. Okay. So cut. So what is today's date, guys? Today is March. Modified date did not change. Okay. So I'm trying to fix the problem of my laptop. Okay. What is this? 28 date modified 28. Kubernetes new folder got created, but this has Minikube internally. Okay, nice. So this is already embedded. So what I need to do now? So directly I'll say git bash here. Say Minikube start. Selected. Okay, booting VM box. So this should work. I'm expecting this will fix the problem. Yeah, it's working now. It's nice. So we can run our show now. It's good. So downloading Kubernetes preload. So in the image, we should see something new will come up here. So in 2 or 3 minutes, then we should be able to proceed. It's downloading the image. So we are waiting for this mission to get it done. So almost it will take 5 to 10 minutes, guys. So once it states it started downloading, it will take almost 5 to 10 minutes. So that's a time frame. But while it does, what we'll do is we'll try to see a little more stuff of the Kubernetes. So whether you start, so this is a command to start, or this is the same command to start the installation also. So if the installation is already detected, it will always start the Minikube. And keep in mind, never start the Minikube directly from the VM box, guys. The cluster will not become up. So always follow these commands only. So Minikube start, and if you want to stop, you need to use this command. And this command can tell you what is the kubelet version that you are using. Now, if you want to know how many computers are there in the cluster, this is a command. Because in a cluster, as I told you, you will have multiple, because it is always operates on 2-tier architecture. You will have a dedicated server and clients. So in a cluster, how many machines are there? If you want to know, you have to fire this command. So machine or a server is classified as a node here. So that's the reason it is called kubectl get node. Now all the commands of the Kubernetes that you are interacting with kubectl will use kubectl. Kubectl is also called as kubectl. And the next command is cluster info. So this command will help you to get the properties of your cluster. If you want to know in and out details of the cluster that has been automatically created by the Kubernetes, then if you want to know those details, that is a command. And keep in mind, in a real time, cluster is not created by DevOps. Cluster will be created by Kubernetes admin. Because if a company is using Kubernetes, then definitely 2 or 3 people are required on Kubernetes. So one guy definitely will be a developer. Another guy definitely will be a admin, and third guy is a DevOps. So these 3 people are mandatory. So cluster does not come under DevOps perspective, guys. Cluster creation is a role and responsibility of admin. So they will take care. So once the cluster is done, if everything is up, now we take responsibility of placing the applications on the cluster or getting the applications deployed on Kubernetes. That is our role. Okay. Now, to have more information, so the port of Kubernetes server is 8443, guys. So the default standard port number is 8443. And here in a Kubernetes, you will hear a words called control plane, guys. So there is a specific name called control plane. If you hear a word called control plane, that is nothing but the master server. So from wherever the administration is happening, that is called, see, best example to make you understand. So let's say IBM. Everybody knows IBM. Please confirm. Everybody knows IBM, guys. I hope everybody knows IBM company. So in India, tell me where is the headquarters of IBM? So we have IBM Hyderabad, we have IBM Bangalore, we have IBM Chennai, we have IBM even in Vizag also. We have IBM in Pune, we have IBM in Mumbai, right? So a lot of centers are there. So I hope you are getting. So in a architecture of the cluster also, we have a lot of servers. So the one that says control plane is the master, like headquarters of IBM. Though it has different centers, Bengaluru is the headquarters. Clear? I hope you understood this example. So in your Kubernetes infrastructure, the main server which is controlling everything is classified as control plane. So let's see if the cluster got created. No, it is still downloading. Let's preload. Okay. So let's take down more points. So when you fire this command, you'll get entire information, but we'll fire this once the mission is up, but this is a glimpse. So this will show you how many missions are there in a cluster. This will show you the cluster properties. Is it audible, guys? Confirm, is it audible? Okay. Yep. So cluster properties, if you want to know, we have to fire a command called kubectl cluster info. And the default port number of the Kubernetes server is 8443. And the control plane is technically referred as master server, because in Kubernetes infrastructure, so you'll have multiple machines, and multiple machines are capable of playing a role as a server also. But the main guy, the master guy, is classified as control plane. Now, coming to the important knowledge in the Kubernetes, what you see on the screen. So Kubernetes contains 6 core components, guys, in entire Kubernetes. Like in Mahabharata story, we'll say, okay, these are the people. Likewise, in entire Kubernetes, there are 6 people out there. So these 6 people, guys, are important, and this is generally they will target the interview, guys. Got it? Generally, they will target in the interview. So what are these 6 core components? So first one is API server. Please write this, guys, because 80% chances are there that this is the highly asked question in Kubernetes. First of all, normal basic question is what is orchestration? Second basic question can be why do we use Kubernetes? Third very basic question is what are the core components of cluster? So API server, etcd, kubelet, container runtime, and controller and scheduler. Okay. So I repeat once again, it is API server, etcd, kubelet, container runtime, controller, and scheduler. So there are 6 candidates are there, and all 6 candidates are important now. Each component or a candidate is capable of handling something. So what is that? Let's see. API server is responsible for managing all the cluster traffic, guys. So any traffic that comes in to the cluster and any traffic goes out of the cluster, that is under the supervision of API server. Okay, that's one of the component. The next etcd. So whatever the data that are happening in entire cluster, data transactions, everything is managed by etcd. So etcd takes responsibility of data in a cluster. Kubelet. So this is a guy who works as a mediator between the different services in Kubernetes. So like API server is one component, etcd is one component. Likewise, we have multiple. So to talk or communicate between this each components, Kubelet is helpful. The next, container runtime. So this service is responsible to manage the containers live. Okay, processing. Controller. So this is capable of giving the directions towards a containers, guys. So any containers, if you want to change, so if you want to impact the behavior of the containers, so we have to use controllers. So controllers is responsible for changing the behavior of container. Let's say from stop, it can go to start. From start, it can go to stop, restart, run, exe. These are all behavioral changes of containers. Scheduler, the last person. So scheduler takes responsibility of load balancing the containers in a cluster. So let's say hundreds of containers needs to be created. So it understands which cluster is free or which machine is free, and it accordingly distributes the load in the cluster. It is like a load balancer, guys. So scheduler takes responsibility of scheduling the containers in a cluster and acts as a load balancer. 6 components, 1 keyword. API server is all about traffic. etcd is all about data. Kubelet is all about mediating, something like a mediator between the services. Container runtime, managing the live containers. Controller, behavioral changes of container. Scheduler, load balancer. That's it. So just remember the keywords, then you will be able to talk on it. So that are the core components of Kubernetes, guys. Then if you want to know whether all the services are up or not, you have to fire this command, minikube status. So minikube status is a command. When you're using minikube, guys, you have to use minikube status. But in a real time, you guys will not use minikube. You will use a production grade. So under that circumstances, you are supposed to fire this command, not this. Since we are practicing on minikube, this is sufficient. And this command will help you to check whether the services are up or not. So simply it will tell you the service, what are up. So that is the use of benefit of this command. Any one service does not work because these are something like core components like eyes, heart, kidney, right? So anything that is not working here, Kubernetes will be infunctional. So you will see the functional impact. So make sure that all the services are running in Kubernetes. That is where you expect the Kubernetes to be optimum when its core components are perfect. Okay, so let's see what happened here. No, I think there is technically really there is some problem, guys. So that's fine. What I'll do? Yeah, let's take down the architecture. Okay. Now, once you take down the architecture, then we'll talk about the component. Then we'll see the practice tomorrow. I'll fix the problem by tomorrow, guys. Okay, please take down the architecture of Kubernetes. Now, you people know why it is called Kubernetes is also called as K8s, guys. Any reason for this? There is a short name for Kubernetes. People call it as K8s. Any reason, guys? Any gimmick is there in that word? Yeah, the reason is, if you see the spelling of Kubernetes, okay, between letter K and between letter S, right, there are 8 letters are there. So that's the reason they're given a nickname called K8s. So K8s is a project code internally in the Google, because when this was getting developed in the Google, so this was given a short name called as K8s. So between the K and S, there are 8 letters in between. That's the reason the short name is K8s. Okay, now let's jump in and understand very basics. So fundamentally, Kubernetes comes under 2-tier architecture system, guys. So these are all common words, but let me write one. So let's say this is the server. So very common points are what? So this is a 2-tier architecture system, 2-tier system. That means we'll have a dedicated server and n number of clients. That is a principle of 2-tier. But according to the Kubernetes, the principle is looks somewhat different. Their principle is different, guys. Not every school is same, right? They have their own principles in place. So here, according to the Kubernetes, it needs to have one master minimum. One is minimum, guys. You can have a number of masters also, but one is minimum. And each master should have at least 3 nodes. That is a rule here. This is a thumb rule. They call this as thumb rule, guys. Thumb rule means like for our hand, we have 5 fingers. They say one server should have minimum 3 nodes. You can have more than 3, but not less than 3. Minimum 3 nodes. That's a thumb rule. So let's say if you're setting up two masters, then logic looks like 2 servers, 6 nodes minimum. You can have n number max. So that's a principle. Now let's imagine this is a Kubernetes. That means on this we install a K8s. Okay, one bumper offer is whether you like it or not, like Docker also gets installed. The reason why Docker gets installed, guys? Any reason for this? I told the compiler to install K8s, but it is installing Docker also. I think I told you in the beginning, last session, why Docker is required. Default engine, because Kubernetes as on today does not have any its own engine. So it sits on somebody's engine. So that somebody is nothing but Docker engine. So that's a default. Right? Okay. Now what we'll do is, so when you install the Kubernetes, it will automatically install the Docker. So that is what we know. But on the client side, as you know, let's assume this is our client side system. So definitely you'll have three missions. One, this is 2, and this is 3. Right? This is what 3 missions. Minimum 3. You can have more, but minimum 3. So this fellow sitting in this box, what they are called of? So these are called minions. We already know it. I already told you. Minions, or these are also called as worker missions, guys. Minions are worker missions. So on every client also, we need to have Kubernetes installed. Keep in mind, K8s needs to be installed on every client also, on every node. K8 needs to be installed. Now, how this works? So wherever, whatever the machine that is acting as a master, so let's say this is a master. Okay, master. So that's the reason technically this is referred as control plane. So on this also you'll have a cluster. Keep in mind, wherever Kubernetes is there, cluster will be definitely will be there. So let's say this is one cluster. It sits here. So copy of this. Okay, so we'll write one more cluster here. So here also you'll have cluster. And here also you'll have cluster. And here also we'll have the cluster. Now the logic is, now subject keeps on getting updated, guys. So this is the one tool, and another tool is Chef. So avoid watching YouTube videos because Kubernetes is still evolving. That is the reason. I repeat once again, Kubernetes has not reached climax. Kubernetes still like a Bahubali movie, so many years they took now. So this is still going on. So we have not yet reached the end. The subject looks a little changing from time to time. So better you stick to the standard documentation of Kubernetes, guys, only. Okay, avoid watching YouTube videos for this. So that's a recommendation. Okay, the reason is subject is still evolving. Now, in the Kubernetes, so let's say we got a request. Let's say there is a demand coming up that we need to create some hundreds of containers. Imagine containers need to create. So what happens is, so servers understands because it has connection with this guys, right? 1, 2, and 3. One more connection. So server knows which client is free or which node is free and where to establish. So what it does is, so let's say it may create some clusters here. May create, so I'll put it as a star. So it may create some clusters here. Sorry, some containers here. So let's say this is some containers. Now again, one more request came in for again few more containers. Now it went to the So I'll give some numbers so that it is easy. So let's say this is 1, this is 2nd, and this is 3. Okay. Now the question comes is, so let me exit this chat. So they're bumbling like anything. Okay. So when the first request came, I went ahead and created my containers on the cluster 1. When the second request came, I felt that this second machine is super busy. Then what I'll do, I went on to third and created my cluster, or meant to say my container. So now you need to remember one very technical important point is wherever it is creating, server remembers the data. So it will remember its story. Okay. I created the cluster 1 on this machine. I created some containers on this cluster. I created some containers on this cluster. So whatever I draw on this cloud-like symbol, these are called config files. So server knows the configurations on which machine, on which cluster, how many containers are there, where it created, and where are the rest of the containers. For example, one more logic. Let's say I got one more request. So what happens is that first of all, the config file gets created. As you know, the config request happens here. Now, once the config request happens, so now the configurations have to be distributed. That means the containers have to be created. Now, what happens is it checks that on the server 1, there is some space. So it will create 1. But it is not yet finished. There is no enough space on cluster 1. So it will move to the 2. So it will create few here. And this is also not sufficient. It will try on 3. There is some space. So here. So what happens in config files is it will write that the containers are operating on the cluster 1. This config containers are also operating on cluster 2. And this config containers are also operating on cluster 3. So you're getting, guys, what I'm talking. So whenever the request is coming, it maintains a kind of a config file. If you talk in between you and me, I can say that's a biodata file. So it will remember what is happening on which machine, on where it is getting distributed. So this is one logic. One more logic. So let's say one more use case. Let's say I got one more request where I created one config file for configurations. So now I'm trying to go ahead and see which machine is free. It found that either 1 or 2 or 3 are not available. You understood? They are busy, super busy. They don't have space with them. Okay. I'm talking about very different use case. The different use case is earlier I thought about space was available or availability was there. Now this time I'm talking about where all the rooms in the restaurant are full or in a hotel are full. What do you do? Guys, tell me. I think you might have faced this kind of situation in your lives. So when you go to the pilgrim centers, sometimes you will check in the hotel and you'll see that it's damn full busy or it's full. What do you do, guys? I'm talking about that kind of situation. Another hotel. Yeah, right. So if not this hotel or another hotel or next hotel. So let's say if the most hotels are busy. Let's say you guys have traveled in the car. What do you do? So this is not possible, but technically I'm telling you, in very rarest of the case, we'll feel that some people make a car as their home and sleep for take rest, right? We have to spend the time in car only until hotel is available. Correct? Apply the same logic here. So when our machines are not available to take up the load, server takes up the responsibility of hosting the containers now. You got it? You understood now what I'm talking? Is this easy? So when our clients are super busy and they don't have enough space with them or nor they have the availability with them. So because of no chance at the node side, Now control plane takes the responsibility of hosting those containers on the cluster, on the server itself. Okay, it keeps remembers that, okay, I hosted on my machine itself. Now, whenever there is an availability, it will simply transfer that over there. So let's say this one. Let's say I'll pick up this guy. Or so let's say I'll pick up this scan data. So simply it will transfer onto the so and so machine. That is what it does. You understood, guys, what I'm talking? The example of an hotel. So when the rooms are not available, we have to spend some time in the car or whatever you traveled. So we wait until it is the same logic. When the clients are super busy, no space, server will take responsibility of hosting all the containers on it upon its own cluster. And whenever availability is there, it will simply again transfer back to the cluster. So this is one advantage. Another greatest advantage is every fraction of minute, the product is designed in such a way that it checks the health check of the cluster. Health check of cluster. This is one wonderful thing why the Kubernetes is great. So it keeps on checking whether cluster one is good or bad. Every minute, guys, every minute. It has an algorithm in place. For every minute, it reaches out to the cluster and checks like a doctor. Okay, are you good? Cluster one responds positively, then everything fine. So in its checks, let's imagine that if in the cluster one, if the checks have failed, that means the health of the cluster one is bad. So automatically it senses the signal, and what it does is server looking into the server remembers, okay, what containers I have hosted here, right? Let's say these two, and it opens up its config file. Let's example, these are two its config files. What it does is it recreates the configuration, recreates and distributes that, pushes on to the another best machine which is available. Or you can say it recreates the configuration knowing that that machine can go down or some damage, or you can say it is down. So automatically it recreates the configuration and pushes on to the available clusters. So even if my cluster is down, am I worried now? Tell me, guys. Suddenly take it for granted, even if my cluster is down, am I worried? No. That is the reason in Kubernetes, the downtime is 0. Okay. That is the reason in Kubernetes, the downtime is ground 0. So it is not possible. That's the reason they given the formula of having one master, 3 servers. One master server and 3 node servers. So let's say if this is failing, all will move here. Okay. Or here to here. Or if there is no space, they will move here. It gets created here. So there is no damage technically. So the probability of giving the probability of going all the 3 down is 0. Am I true, guys? Do you think all 3 will go down at same point of time? Is it possible? So architecture wise, what they do is in the architectural design itself, they'll keep the server 1 or the cluster 1, let's say North America, cluster 2 somewhere in South America, and cluster 3 somewhere in Europe. So I'm just taking an example, guys. So it does not mean that they are so different parts of the world. I'm just taking an example that all these servers will not be in the same building, guys, because as you know, because we need to maintain the policy of backup. So one server may be in some state of US, another server will be in different state of the US, another server will be in different state of the US. So that means they are geographically located not at the same place. They are distributed at different geographical location. So that is how the architecture is designed here. Now considering this, keeping this logics in the brain, so there is no downtime in the Kubernetes case. There is one more chance here. What if, one more clue. What if the server went down? This can possible now. Yes or no, guys? Yeah, that is also possible. This is possible. I'm just taking an example, possibility only. This is also possible. So under that circumstances, right? So architectural wise, they keep there is an algorithm already in Kubernetes. So architectural wise, they keep the backup of all these configurations somewhere on the client only. On the client. They replicate onto the client. They'll try to replicate. This is one mechanism. Or they will create one more server and they will try to replicate here. They'll do this. So either one or two. It depends on the company's budget and their strength and capacity. So if they don't want to buy one more, they'll use the client as a backup server. So let's say if the server is down, one of the three guys here will act as a control plane automatically based on algorithm. One of the guy among the three will act as a control plane for some time, and the rest two will act as subordinates. So that is the wonder of the Kubernetes mechanisms, guys. Are we clear on this? If we have already arranged one more master server, which is trying to replicate all the configurations there. So if the master server is down, secondary server will become up and talks to the clients. Clear? So this is the role of the entire Kubernetes in simple. And technically, all this setup and everything is under the role of your Kubernetes engineers, guys, Kubernetes admin engineers. So they take up responsibility of setting up the Kubernetes, setting up the cluster, setting up these backups, setting up the configurations, and setting up this load balancing. That is their role. So what we do, our responsibility is push the applications. This is what we do. So we push the applications. Our duty is to get the app and get it loaded on the cluster here and scale, set up the scaling options. So end-to-end application maintenance is our role. So take down this diagram. I know this looks very dirty, but I want you guys to take down this bookish diagram, which looks nice. So this is the master server. Okay. And there is no failover mechanism. If one fails, automatically the load is balanced on other two. And according to the algorithm, there is no possibility of having failure at all. Okay, really my machine is a trouble, you can see. So I'll take care of these things today, but I want you to complete this architecture theory part. Is it done? Now next step. Next thing is we have to study about Kubernetes components, guys. So this is also important. The reason is I just told you the in generic at an upper level, what are the core components of Kubernetes cluster. But when you create the completely the multi-node cluster setup like a real time, the components are looks somewhat different, but most and these things are same. Just one or two items will come extra. So let's see. On a server side, you will have Kube API server. It is nothing but same API server. etcd, Kube scheduler, and everything is common words, guys. Kube. And control manager, nothing but your. This is cloud manager allows you to talk to the cloud instances or cloud nodes. This is a traditional. This is scheduler. We already told. This is data. This is traffic. Now kubectl sits on the client side. Remember, as I told you, there are six. but you need to know where are these 6 are located. Okay. So kubectl is not on the server side, guys. Kubectl is on the client side. There is one more component called kubeproxy. So kubeproxy takes responsibility of network. Okay, network on the client. So on the client side or node side, anything relevant to the network ports intrusion, or you can say hostings, it is taken care by kubeproxy. If kubeproxy is down, your application will not work. So kubeproxy allows the application access the container runtime. So this takes responsibility of managing the containers which are live. So as I told you, so if I ask a question, you need to tell me, guys. Just a question. Now we already saw that table now, just a simple question. API server, is it on client side or server side, guys? By looking at name, you should tell. API server, is it client or is it a server side or a client side? It's a server side. etcd. You should remember this in your brain, guys, because this is one of the very commonly asked interview questions. etcd. This is server component. Kubelet, which component? Is it server side or client side? Node side. So kubelet, I don't think so it is a server. See, kubelet comes under client. So you have to remember like a match the following. Okay, runtime. Runtime. Is it a server or a client? It's a client. Controller. In short, control manager, server. Schedule manager or scheduler, server. Now the last one, kubeproxy. Kubeproxy is a server or a client? Client, right? Yep. So that is what I'm trying to tell you. So you have to remember which component works on which end. Okay. So that's a thing. So we'll stop it here, guys, because our Docker is, I mean to say, this setup is not great. So rest of the things, entire story revolves around the commands only. So I'll get this fixed today, but I want you guys to mug up this, by heart this controllers, and also spend little time on investigating on these words, guys. What is this proxy? What is this? Okay, tomorrow we'll start pods. Pods is nothing but containers only. So we'll see that tomorrow. Did I update the notes in the last class? Okay. So if you have any of your friend circle who is got 5 years of AWS experience, please approach me. I have some opening in reference. I can help them. The candidate needs to have DevOps knowledge with AWS 5 years experience. So Shashul Ahmad, yeah, we are both traveling in both same boat. We have to figure it out why it is coming. So definitely we can fix it. So there is a famous saying is if there is an issue, then tell me, do you think God will create all the issues unnecessarily? This is what you have to think, guys. This is the biggest lessons of life. Do you think issues will come in life for unknown reason? If an issue comes, definitely there is a solution, right? For everything, there will be a solution, guys, except death. So we are all human beings. We need to know that fact. So you have to strongly believe that we can do anything except death. So we cannot manage it, we know it, nor we can control the birth, nor we can control the death. So between birth and death, everything is possible. Every issue has a solution. Am I clear? So keep that philosophy in the brain. and work very strongly, guys. You have to believe in yourself and see what you can do tomorrow. You have to imagine, and whatever it takes for it, please work on it and put right efforts. So, and one more thing you have to know. So, there is a famous saying also, Sabka time aayega. Am I right, guys? Sabka, in Hindi, there is something nice word is there. Yeah, sabka time aayega, but not everybody will have the same time. Correct. Don't think that luck will favor everybody at same point of time. So luck will come at different times, differently, for different people. But we have to continue our work. Right? Got it? Yeah, sabke saath, sabka vikas. Nice. Yep. Okay. Thank you, guys. And please, let's catch up tomorrow. And those who are interested, what is this? I'm getting an error while doing Docker project LinkedIn installation. Any idea? Naik, please try to switch to different network and see. Naik Rajat. Okay. So generally that error will come if your internet is not great. If internet is slow, that kind of problems will be there. Okay. Yeah. Fine, guys. So that's all. And those are interested to do some internships, guys. So 20th, we have little admission where I work as consultant. So if you're interested, please follow up with me so I can get you enrolled on for 20th, guys. Yeah. So see you. And if you want to have feedback how that works, we already have the people who are doing it. I hope Kavya does it. Who else? Dashul does it. So you can have review with them, talk to them and see how it is favors for you. Sushmita also does it. And if it favors for you, helping you, definitely take advantage, guys. Yeah. Thank you. See you. Bye-bye.